What's going on, everyone? You're welcome once again to DWH channel. On today's video, we're going to be continuing our series on data modeling in data warehouse, and I'll be focusing more on dimensional modeling. If this is your first time, thanks so much for coming, and if you're a returning viewer, thank you so much. Please don't forget to hit the like button and the subscribe button, and also the notification bell so you can be notified once a new video drops in. Alright, so let's hit the ground running. So, what are dimensional models? Dimensional models help define business processes and their individual events in terms of measurements, which we call facts, and their descriptions, which we also refer to as dimensions. And with these dimensions, they're able to filter, group, or aggregate these measurements. Let's say we have a simple sales process that has three dimensions: dimension of product that talks about what was sold, time that talks about when it was sold, and let's say location that talks about where it was sold. These dimensions can easily be represented using a simple dimensional data cube, right? You can aggregate or group or filter these facts measurements using these three dimensions of location, product, and time, right? Now, this is very good and very simple for items or business processes with little dimensions. Now, however, in the real world, we understand that business processes could be very complicated with several facts and many more dimensions, and it will be difficult for you to visualize these things using a data cube. Now, this brings us to the point of the star schema. The star schema, as the name implies, allows you to visualize many more dimensions with your facts being in the middle and your dimensions all around your facts having the picture of a star. While it is difficult to envision models with more than 3 dimensions on a multi-dimensional cube, it is much more easier to do this on a star schema. Star schemas basically are used to visualize dimensional models, and I also used to describe the physical implementation of dimensional models as relational tables. Star schema comprises of facts and dimension models. Your facts being your measurements, and the dimensions being your descriptions that gives context to the fact. The facts contains numeric or quantitative measurements of your data, and the dimensions contain qualitative or contextual details of your data. So dimensions contain a set of descriptive dimensional attributes, or columns as we may call them, that helps us to filter data or group data for aggregation, group our facts data for aggregation. Most times dimensional attributes often have hierarchical properties such that allows us to drill down, like from top to bottom, right? For example, you're trying to drill down from year down to quarter, month, and then week and day. That's the thing. It allows us to have that kind of a drill down. So dimensions can also contain numbers and dates too, but then these numbers and dates are not additive in nature. They just allow you to provide context to your facts or to your measures, right? That's the thing. Generally speaking, your dimensions tables are smaller, whereas your facts tables are usually larger, right? You could have a fact table that comes with 8 to 20 dimensions, right? But those dimensions, each of them are usually quite smaller, right? The most useful facts are additive measures that can be aggregated using the available dimensions that you have in your model. And the most useful dimensions provide a rich set of descriptive attributes that are very useful to your BI users. So the most obvious advantage of a dimensional model in data warehouse is its simplicity. It just gives you a very simple view of how your facts and your dimensions relate. So just at the middle is your facts. You could see just a bird's eye view. You could see how the dimensions give context to that fact. So for example, if you wanted to see the relationship between product sales by location, you just do a join between your product table and your location table through your sales facts table, and then you can make sense of that data, right, in a very simple way. And this also helps you to easily construct the necessary queries you need to pull out data you need for business intelligence. Another important but less obvious advantage of dimensional model is that they are process oriented. The best dimensional models are those that come from asking business questions about the business process, that talks about the where, the what, the why. And this brings us down to what we call the 7 W's framework of dimensional modeling. So what is the 7 W framework? The 7 W's are interrogatives. They talk about who is involved, what did they do, what was done. You also talk about when did it happen, where did it take place. You also talk about how many was recorded, how much of it was done, why did it happen, and then how did it happen, or in what manner did it happen. So asking and answering these questions about the business process would help you identify the dimensions you need to get the most out of the business process or your facts tables, and also give you context to building your dimensional model for as regards your business process. I should just say at this point that one of the reasons why dimensional modeling came up so strong was because at that point in time storage was expensive, and so they had to look for ways to manage storage in their databases or database, as the case may be back then, right? But in today's data space, where we now have lots of cloud ecosystems, cloud data warehouses, storage is much more cheaper and compute is much more expensive. I mean, I've seen the rise of other modeling methods within data warehouse, right? And we have the one big table that is also like coming up very strongly. So at the end of the day, it's the best model you use for your data modeling in your warehouse is usually quite subjective or based on your use case, right? As we go on further in this series, we're going to talk about other data modeling methods in your data warehouse. So to meet again in our next video, thanks for watching. Bye bye.